We have Zach and Drew talking about black teaming.
Is muted. All right, hello, tech crew. Yeah, RIT tech crew. Okay, welcome to Black Teaming. I'm Drew Young,
I'm Zach.
networking price.
Okay, thanks.
And we're gonna teach you guys about black teaming. We're gonna go over what black teaming is. But first, we're gonna start with who we are. I'm Drew Young. I'm a fourth year. I'm from Massachusetts. I'm working at SRA. When I graduate, actually, on their advisory grad department, so I'm excited for that. I work for Tech Crew, RIT Tech Crew. That's a beautiful place to be. I like hockey, like the Bruins. From Massachusetts, go Bruins. And RIT hockey. They were better last year. Red Team Chief. I'm the chief of the Red Team. I'm on ops. I'm on CCDC. I was the info lead. That's black team right there, by the way. And yeah, Munson's my best friend.
Hey, I'm Zach. I'm a fifth year BSMS student. I currently work for the federal government. I am the former ISDS and CTFCA. I was also on the CCDC team with him, unfortunately, and I'm also on the red team.
Quick agenda for here for this meeting. We're gonna go over the competition types. We're gonna go over the organization of black team. We're gonna go over Terraform. We're gonna go over Ansible. It sounds quick. It won't be that quick. We go pretty in depth. So, all right, let's get started with competition types. Zach is gonna kick us off with red versus blue.
All right, so this is our red versus blue. This is the two competitions we run here are primarily red versus blue competitions. So you get, typically it's virtual environments. The themes and the environments will change a lot of the time depending on the competition. You have a lot of different blue teams defending an infrastructure, and then you have, usually, it's a singular red team that's at the center trying to attack all the different teams. So, for example, RITSEC, which just happened 2 weeks ago, ISTS, which is happening in the spring, UB Lockdown, and CCDC. Things like that are all traditional blue versus red competitions.
Another type of competition is a CTF competition. A lot of people here are probably familiar with that, especially with like Contagion, if you go to Contagion. So what this is, it's kind of like a Jeopardy style competition. So there's a bunch of different categories of challenges, just like there is in Jeopardy, and then a bunch of different levels of challenges. So from usually easy to hard challenges. So in that case, it'd be like the money value of how hard the challenge is, how difficult the question is. And there are just a bunch of puzzles or challenges for you to solve. It can be like forensics, it can be pwn, it can be web, stuff like that, different categories. And some examples of this is if you compete in like the RITSEC CTF or the WISA CTF. There's also like CSAW, which is like the national one. But yeah, the ones that we host are the RITSEC CTF and the WISA CTF.
Cool. Next up are King of the Hill style competitions. So these are usually either independent or team-based competitions where there's just a bunch of boxes sitting out on a network that you got to try and pen test, essentially. So a lot of pen testing skills are required, a lot of exploiting vulnerabilities in order to get code execution, things like that. You typically know next to nothing about what the environment really looks like outside of a subnet, and that's it. A lot of intentionally vulnerable things like FTP or things like that. You gotta get in, take over the box, kick people out if they try and get in, just hold on to it for the duration of the competition. So we run two here. One is during ISTS, we run a King of the Hill, and there was also Cora a month ago.
Setting up these competitions is your students you see around you. It's also sometimes big organizations like CPTC or CCDC who are actually running these competitions. And all these competitions will have what's called the black team. And black team is the people who actually set it up. And that's what this whole presentation is about. So this is kind of like the organization of black team. It typically has a competition architect, which is kind of the person who decides on like the theme. We'll go into all this more later too, but they do a bunch of like the general oversight of the competition. This year we're having like a black team lead, so in that case it's Ariana Schwartz. And then there's like black team leads based off the black team lead who kind of lead their own individual groups, which again we'll get into later. And then there's members that report to their leads. So this is kind of the overall structure of how the black team flows.
Yeah, so starting off at the very top, so this is what I was and Drew currently is for a competition. So this is the person in charge for the competition no matter what. You are the project lead for it, so you're in charge of every aspect that comes to it. So you're coordinating with your black team, you're coordinating with white team, you're coordinating to make sure the blue teams are all okay. You're also working with the red team to make sure they have everything they need. Everything is like you're talking to essentially hundreds of people trying to get things managed and everything like that. So you have to decide the theme, you have to decide the network topology, you have to get food for the competitors, you have to handle any reservations that need to happen, teams. So for ISTS, we have teams that come from across the country from a bunch of different universities. They're college students as well. You can imagine trying to wrangle 75 to 90 college students to get to a place at a certain point all across the country when you're only platforming to talk to them is just through Discord. Sometimes they don't respond for a week because they don't look at their phones. So there's a lot of different aspects where you're usually and hopefully for the duration, if you're the CA, you are entirely non-technical because you have so many other things to focus, which is why you have your black team. So you don't have to do everything yourself. You can kind of delegate setting up the stuff to other people while you're trying to get everything else organized so that the competition can actually function outside of just the infrastructure being up.
So that's our CA. That's top dog. That's the big cheese. That's everyone of the that's like the man of the competition. Now we have the teams who actually report up to the CA, who the CA can like delegate tasks to. So the teams that we typically have, and a lot of these are actually only seen at like ISTS instead of RITSEC, but we have infra, we have Windows, Linux, scoring, Injex, logging store, and then the ones that are just seen at ISTS is usually game, CTF, Koth, and WeirdOS. Yeah, Lucas is our Koth lead, so he's excited. The more technical ones of this list are infra, Windows, and Linux because those are the ones actually like setting up the services, setting up the infrastructure. We'll get into a lot of that later as well. Setting up like the actual competition room and like details about the competition is more of like scoring and logging. They're the ones who are kind of planning like, okay, if we need to look at logs during the competition, this competitor did this, or someone broke the rules here, logging's doing that, scoring, setting up all the score checks. And then non-technical, we have Injex in the store. Those are the ones that are kind of keeping like the theme of the competition alive. They're the ones making sure the blue teamers are having a good time, the red teamers are having a good time, stuff like that. So beginning with the black team lead, actually, Zach's gonna kick this one off because this was his idea for a role.
Yeah, so this is a new thing we're gonna try out with ISTS. This is sparked from when I was the ISTS CA. I became very overwhelmed with the amount of stuff I had to do with both managing black team and managing all the other aspects of the competition. It became a lot, especially when I had a team from a certain western state of California drop out maybe 24 hours before the competition started. They go, oh, I guess we don't have a flight. And I was like, okay. So yeah, that was a lot of fun. And by fun, I mean very stressful. And primarily it was because I was split between trying to manage the black team and manage the competition itself. So I wanted to kind of have a person that's under the CA but above black team that is just there to manage the black team themselves. So they've been on black team, they've been a black team lead. Their whole goal is just to be there and help manage the black team. So if something happens, everybody doesn't immediately scramble to go to the CA to try and help, to try and like fix everything. So they help flesh out the vision that the CA has for the competition. So if there's like theming questions that don't really need to be brought all the way up to the top, they can just ask the black team lead and they'll go, yep, this is how you would do it, or these are the users, or things like that. And it also helps keep black team accountable for the deadlines that are happening. So if we want to have the competition up 2 weeks before, the black team lead's going to be the one driving that while the CA is trying to make sure we have the food and the money and everything we need for the competition itself.
As mentioned earlier, the black team, the CA was the big cheese. You can refer to the black team lead as the medium-sized cheese. So moving on, we have infrastructure. This is what I was for a bit. I love infrastructure. So the main thing that infra does is we'll use Terraform to deploy the actual environment, the actual machines, all like the Linux, Windows, routers, networks, everything that gets deployed on OpenStack is done by the infra team. It's done with Terraform. That's how we automate things. We can kind of reuse it year to year if things don't change too much. You have to change a few things here and there if we have to like change some things on OpenStack or different subnets, anything like that. But typically, it's all around the same type of thing. Hence the reusable infrastructure as code. It kind of saves a lot of time when we're doing so many competitions. Using last year's stuff is actually very, very helpful for that. You manage the hypervisor running the competitions. The hypervisor we always use is OpenStack. It uses QEMU under the hood. So knowing OpenStack while being on infra is very, very important. We also use Ansible to set up all the management services. So the services that the teams don't set up themselves, like the Windows Linux teams, the services that are like everyone relies on, so like DNS for the competition, NTP for the time across all the DCs, the VPN, so red team and black team can access the infrastructure. Uptime Kuma will show us what boxes are up, if DNS is working, stuff like that. So that's what we use Ansible to set up. We also like manage dropping keys for everyone, giving all black team access to everything, and just kind of like assisting the black team anywhere they have questions. We also configure competition networking, whether that be like physical or virtual. So physical networking, we might go in and configure the switches, and then virtual, yeah, we'll set the subnets on actual OpenStack on all the networks. This is this is a real picture from the server room this year during RITSEC. Yeah, we had a lot of cables running around, so.
All right. First up, here we have our first actual operating system team. So we have 2 of these teams. Windows is responsible for any Windows services we have up on the competition. So usually we try and get a 50-50 split. It's usually nicer to have a 60-40 for 40% Windows, 60 Linux, because Linux is just easier to set up, honestly. So one of the first things they do, figure out what version we're running. So 10, 8, 95, XP, kind of feel out how you want to do it. And then also server 2022, 2016, 2012, things like that. So a lot of the domain controllers, we kind of just will look around and try and set things up for. So usually the operating systems themselves will be decided by the CA, and then it's kind of responsible for the teams to implement different score checks and different services on the boxes themselves. So traditionally on servers, we'll have like Active Directory, certificates, domains, things like that. And on boxes, maybe we do like an LDAP check or things like that. Nothing too wild on Windows because it is a very finicky beast to try and wrangle with. It always throws a problem no matter what you do with it. Another thing to consider, I'm sure many of you have already dealt with this before, Windows Defender, it is a pain to try and just shut it off for 5 minutes because it'll turn itself back on. We also don't like having Windows Defender on because we like to have red team use stuff, and Windows Defender loves to catch everything red team related. So there we have a whole script that's purely focused on killing Defender, and it like takes out like 15 different areas so that Defender can't turn itself back on. And it's just setting up users as well, they're responsible for. So that's both we'll have local users and domain users. So that's spinning up the users locally and then spinning up a domain and then adding the users on top of that. And like I said, services, Active Directory, SMB, WinRM, IIS, MySQL, things like that.
Then we move on to Linux, arguably the better operating system. It's a little bit easier to set up. Again, the same thing as Windows is how they have to set on like Windows 95 versus Windows XP. We did the same thing with distros for Linux. We'll decide on Debian, Ubuntu, FreeBSD, maybe a little bit of Hannah Montana Linux or Debian, those who know. So yeah, they'll make those images. That way Infra can deploy them. They'll usually work with Infra to actually do that. And then what they have to consider is actually installing all the packages, setting up the services, configuring everything on there. They'll have to drop all the users. They'll drop everything that the boxes like rely on. If one machine relies on another box, they'll make sure to set up those in that order. All the score checks pretty much for this service rely on that team. As Zach mentioned, it's a lot easier to do Linux. A lot of the things can just, again, be reused as we did in previous years, but typically we fit things to theme. So we'll modify things for different competitions. But a lot of the baseline stuff is pretty much the same. And then some things that we'll actually throw on Linux is SSH, which is just pretty much set up by default, secure shell. I'm pretty sure you're all familiar with that. FTP, which allows us to transfer files. Web, we'll throw a few websites up, maybe using like Nginx or Apache. MySQL, we'll have a little database containing some information. Usually it's, again, fitted to the theme somehow. And then ICMP, which is just a nice, easy one to have. That's typically used on machines like Hannah Montana Linux that can't install any packages or something like that because we do a few weird OSs in ISTS.
Next up, we have our logging team. So they are responsible for setting up and monitoring logs throughout the competition. So what we do for our logging platform is we have this great tool provided to us by an alumni called Datadog. It's a logging company that really any company can go to help set up their logs, things like that. They gave us essentially a free blank license to do whatever we want with. Probably use like 100,000 a year that we should be paying, but they don't care. So we're students, yippee. The benefit sometimes of being a student. And again, provided by an alumni, so if we ever have any issues or anything like that, we can go to them and be like, hey, is there anything we can do differently or anything you guys can help us out with? They've helped us out before. They've provided us with patches at some point when stuff wasn't working. They're also responsible for making sure teams are following the rules during the competition, where it's way too hectic for anybody standing behind you to see anything. They'll be able to tell if like, oh, you're disabling the white team user, or oh, somebody just booted up virus total. Then that team gets yelled at. They're really able to query the logs to investigate anything that happens. So if there's an issue or we find out later on that we think a team, for instance, spun up Windows Defender when they shouldn't have, we go back, we check the logs, we go, okay, point penalty for this team if it proves it. Or if we check and it just was something else entirely and we just got it wrong, then there we go. So it allows us to actually investigate and figure out if something's wrong. And then they also will now work with the different OS teams if we're setting up and giving logging to the individual teams. So during the competition we had, what was it, Grafana? Yeah. So they worked with the Linux team to set that up and make sure it was available to the different blue teams for RITSEC as well.
Logging is good for any organization, but it's good for us during competitions to be able to see what people are doing without actually watching them the entire time. Next up, we have scoring. So typically in the past, we've used this thing called score stack. That relies on like dynamic beat. It relies on it's just a big elk stack pretty much, Elasticsearch, stuff like that, which is a really hefty program to run. You also have to run this thing called the beat, which runs off of one machine. So that means every single score check is off the same exact IP address. So there were just a lot of problems with it or things that we just didn't really like. So an alumni of ours, Max Fusco, actually made a new scoring engine called Scoreify that we've used for IRSEC so far. We've used it in CDT for a few competitions, and we're going to use it for ISTS this year. So Scoreify lets us do the things that we didn't like in ScoreStack and actually use it there. So it's a lot more lightweight than ScoreStack is. You can deploy a bunch of different minions, is what he calls them. So you can have like different IPs scoring each check. That way it's not just always the same IP every time. That will make things a little more realistic to real life for all the competitors. That's a very cool thing. So yeah, the main job for scoring is to configure the scoring platform. It's to set up the scoring platform. So they're given the scoring machine from the infra team. Their key is drawn from the infra team. And then their goal is to set up the scoring platform and make it available to competitors, give them all default users, set up all the score checks, everything like that. They might even have to write custom score checks sometimes. So for example, in my CDT class, we set up Minecraft, and I had Max Fusco write a Minecraft score check. It was awesome, and it worked. So that was really cool. It's written in Golang, so he did it very well. But yeah, you can just write like custom score checks for things like that. The scoring team will do this if they have to for certain checks. We want to make them any more custom than they actually have. It's also handling the competition's final score calculation. So at the end of the competition, you're going to see different scores for each individual team, making sure those are like the actual scores, that there were no errors, and accounting that in with injects is also very important to get the actual final score for every team at the end of the competition. Also including like point deductions for like deleting the white team user or virus total or disabling defender or enabling defender, something like that. So they're in charge of all of that. This is an example right here of one of the checks. This was the Big Brother LDAP check from IRSEC. So you can see in the server there, it's templated, so you can just use a certain number for each individual team. And then you have our domain, because Infra set up all that DNS a little while ago with Ansible. You have the ports on. The username, again, is team specific, so that'll change right there. And then the default password to everything. You can also change like what the actual end user is allowed to edit. So if you want them to be able to change the user too, you could do that here.
All right, now we have injects. This is also a thing that I was responsible for a year. So the primary goal of Injects is creating fake business like tasks or requests that just fit in theme of the competition. So it's either things that you have to do or things that are requested, or you have to like go somewhere to do something for different Injects. It's just a break from staring at a computer screen while you're watching your score checks go up and down so you don't lose your mind for like 6 hours. The team is also very helpful when it comes to setting up theming and things like that, as figuring out what team is what, where the injects are coming from, what they're doing, things like that. They make grading rubrics, so whenever you turn in those injects that they have, making sure that they're graded properly, graded evenly. They work with white team to do that and things like that. And then they also will, walk around, pass them out if we have physical ones, or walk around or just yell out like, oh, we dropped on Discord or things like that. So over here on the right, we have an example of I think it was Inject 0 for the competition. So you can see at the bottom, the person who was sending it out, which the Inject team kind of helped create, was from the Crisis Intervention Agency. I'm sure you can figure out what the joke there was of the competition. Then it's just, all it's asking for here is just country name, country flag, national anthem. You just need to turn it in to the Inject team at a certain point. Something new that we brought in with the new scoring engine is the ability to submit injects through the Scorify itself. Before, we were doing it through another custom site somebody had built, and it worked great, but having it all in one place allows us to make things nice and neat. Yeah, so you're just going through, you're working with the CA to figure out how many injects you need, how many injects they want, when do they want them distributed, is there anything specific they want you to see. You also have to work with the other teams to try and come up with stuff. So if the CA has, for example, a really specific operating system they really want to show off, usually some teams don't like to experiment with it. So what you can do is you can write an inject that forces the teams to interact with that operating system in order to interact with it, show off, see what it's like. You'll also sometimes make like red team injects where it's like, oh, go make this user with this default password, or, oh, please change all your passwords to this one thing. I'm in charge, so you have to listen to me, things like that. Yeah, it's a lot of fun. Like I said, I did it for a year. I'd say one of the best memories I have from that is we were printing out all the injects like 2 years ago, and we realized that for one of the injects, we only printed one copy of them, so we could not distribute it out to all the teams. So my solution was I just gave it to a friend of mine, and he just ran away with the inject and played hide and seek with the blue teams until they found him. So yeah, it was a lot of fun. Injects is great. It's also very non-technical, so if you're afraid of doing a lot of technical works, it's not that, it's a lot of fun.
Rana has been the inject lead for the past like 10 competitions or something like that. They're awesome. Shout out Rana. Yeah, not Zach. Yeah, anyways. So then there's also the store. This is Garrett Thompson territory. He actually made these things right here. So the store team, the store lead, they will set up the store for the blue or red teams to purchase things during a competition. So it can be technical things, or it can be just like silly things like, oh, remove Team 5's chairs, or like get rid of their keyboards, or maybe buy a box revert, buy black team help, something like that. The wall.
The wall. Do you not remember the wall? No. So another fun thing we did was in this room we have wall dividers. So one of the store things that we came up literally the night before while we were setting up the room was, oh, what if we let them buy the Berlin Wall? It allows us to have a lot of fun with it.
Yeah, so teams get points during the competition. They can spend these points at the store and then buy cool things, buy fun things, buy technical things. They usually fit to the theme. As we just mentioned, the Berlin Wall for the Cold War theme. That was pretty cool. It allows for like the chaos that you'll see in the competitions, because like you see a team with no keyboards and they're standing up because they don't have chairs. So they're clicking around on their on-screen keyboard like this, hunched over, something like that. Yeah, it kind of gives you some laughs during the competition when you're just like really stressed out of why is everything on fire? Why are there 5 injects due in the next 20 minutes? Something like that. So this is just some screenshots. This is from the score channel that Black Team got to see. So whenever anyone bought anything on the store, it would at store, which was Garrett, and he would go see something like, oh, hey, Team 18 doesn't have their chairs for 10 minutes. Or, I mean, here are some other examples of things you could purchase. Yeah, very cool things. I forget the bot name. What was it? Bot name was Shopping, Shopping, Shopping. That's really cool.
Now we have the white team lead. This is the one that you'll see in a lot of other competitions as well, not just our competition. I mean, CCEC has a white team lead. UB Lockdown has a white team lead as well. So they're kind of responsible for organizing the white team themselves. So the white team is not a part of the black team necessarily. They're kind of just helpers that show up the day of and just help out. So for store, for instance, we'll give the store person maybe 2-3 people from white team, and those people are walking around helping implement the store, helping make sure everything's running great with that. White team's also responsible for helping grade the inject team, or helping grade the injects, because we have 18 teams in the competition, and usually the inject team is like 2 people. They're not going to be able to get through all that, so we help out, give them a bunch of people as well, and then they'll also be walking around answering questions, directing black teamers if there's issues that are arising or anything needs to happen, things like that. So they help ensure the day before logistics, so they come in here, set the room up with everything we need, which is a lot actually. 5 PCs, 5 monitors, a switch, a power strip, all the cables that come with every single one of those, display cables, keyboards, mice, everything that this room needs to be set up with, they have to set up essentially in like 5 hours. So it's a lot. And then the day of. So if we need help setting up food or need help with running some game or something like that, the white teamers usually the ones that are recruited to help out because they're able to be moved around and help out with a lot.
Yeah, if you look around, there's actually 18 tables in this room right now. And we actually bring in more tables too. And there's like a computer at every single seat and more. So that takes forever to set up. It would take so long if we didn't have a white team. All right. We have a few other teams. They're kind of like self-explanatory. These are also pretty much just seen at ISTS. So they're kind of like the shorter ones. So here's the game. This is what Zach and Casey are running this year. So it's set up and run a custom game for ISTS. So the game really every year can either be something technical or non-technical. And it just kind of fits the theme. It gives the blue teamers another way to kind of like escape the chaos of this entire room right here. Go do something fun, get a few points. And yeah, it just is a good time for teams. My freshman year, it was like who can plant the most like backdoors in a machine or something like that. Last year was like you had to take some Nerf blasters. And darts is what they're called. Pick locks, get out of handcuffs, stuff like that. So that was cool. CTF, that's another portion. Again, as I mentioned earlier in this presentation, the CTF is like the Jeopardy-style competition. So the CTF team will actually set up all those challenges. They'll run the actual CTF, keep track of scoring and stuff like that. Then we have Koth, again mentioned at the beginning of this presentation. So they'll set up all the boxes. They'll make them all vulnerable. They'll write up how to do them all. They'll write a little custom scoring engine sometimes for how the actual machines get claimed, things like that. And then there's Weird OS. So it's a very specific OS for ISTS. It's usually one that's not seen in other competitions. It can be funny, it can be goofy, it can be something that, might actually be important. Yeah. Any words on that, Zach?
Oh, yeah. So 2 years ago for ISTS, the person in charge wanted to do Kubernetes, so that was the big Weird OS for that, which was a lot of fun. For mine, my initial goal for Weird OS was, how many people here are familiar with the operating system Temple OS? Yeah, it's a fun operating system. Something I realized early on is that Temple OS does not come with a networking stack. So that's not usable because you need to network in order to put it on the competition. So we ended up trying to find a different distribution that somebody else had made using Temple OS as a base to try and implement it. We spent like 5 months trying to get it to work. Never ended up working. We shifted to like 15 other ones to try and get working. I think we did like Pony OS as well. We did Hannah Montana Linux. We did a bunch of other stuff to end up get working. So you kind of just have free reign when you're in charge. Just pick whatever random operating system you want to see and just see if it'll make sense. It doesn't always have to fit into the theme, but it definitely is a lot of fun to try and just like throw something random at teams that they will not expect at all.
It's one of the benefits of ISTS. There's a lot of like weird things going on. So as mentioned earlier, the Infra team uses a lot of Terraform. It's pretty much only the Infra team that uses Terraform. We'll also get into Ansible later, which every team pretty much uses. So a little overview of Terraform. It's developed by HashiCorp. It's an open source infrastructure as code tool. So you can actually like write out all of your infrastructure, write out all your networks, and then tell it to run, and it will just do it. So you can build, you can deploy, you can destroy. We know a lot about Terraform destroy, Terraform apply. Only infra members get that one. And you can just put a bunch of resources with Terraform as code. It's flexible configuration files with HCL, which is HashiCorp configuration language. It's actually their own language. It's not like YAML or JSON or something like that. It's kind of like a combination of a bunch of things that they've made themselves. Multi-cloud support with different providers is what they call it. It's one of their keywords. We'll get into all these like keywords in the next slide too. But the providers can be anything like OpenStack, it can be AWS, it can be DigitalOcean, it can be GCP, maybe even Domino's, something like that. Yeah, there's a Domino's provider, it's crazy. And it also generates state files, which is the last line here, stateful configuration of resources. The state files just keep track of what is actually deployed, and if you say like Terraform destroy, it'll know what's actually up there, and we'll take those down. So here's an explanation of everything we kind of just went over. So Terraform will give you actually like metadata about the project. Provider is actually like the API for interactions. So as we mentioned earlier, it can be like any of those cloud providers, any of those cloud companies. That's your provider. Variables are dynamic things you can define somewhere, and they're used to just like generalize your config. So you can have like host name somewhere, and then reference or like describe that variable somewhere else. That way you can use the same Terraform again and again and just reference that variable. Or maybe you have to use the same thing multiple places, just good coding practices. There's locals that are static variables, which help you simplify your configuration. Those are a little bit less helpful than actual like variables because you can only use them in that one certain section, like right here. Resources are things that you want to put up, so objects within the configuration. Those are things like, oh, I want to make a network, here, I'm going to make a resource. There's the output. It returns a lot of useful information after you run the Terraform, which is very helpful for us too, to see like what was actually created, see the IP addresses. You can have it output like certain fields, whatever you want, maybe a host name. There's data, which means that this group or this resource already exists in the cloud. I just need to like, go look for it. So for example, during the Terraform for ISTS and RITSEC, things like that, we'll reference like the default security group will already exist. We'll reference maybe a product already exists, or a group of people already exists. That's a data field right there. And then modules you can define. We usually use those for like team lands, team clouds, management, something like that. You can define like a bunch of common objects that you use again and again. Each machine will be a module. It just makes it a little bit easier for us to define one thing and say, pull all the variables from this other place. And there's examples of these, everything we just discussed on the right over here. Here's some more examples of some Terraform. Yeah, nothing crazy here. They'll be in the slides if you want to take a look at them later. But like one of the important ones here is like output instance IP. So when you run this, it'll just print that out so you can see that. And you don't have to like go searching for it anywhere. Yeah, nothing else I really want to talk about. Some more examples, again, in the slides later. You can also, yeah, there's also a Discord provider. So you can like put up an entire Discord server with Terraform. There's a lot of providers. You can just like dig through it. It's crazy. And now Ansible. So we run the Terraform. It puts up the machines. Now we have to configure the machines. That's what Ansible is used for.
All right. So what is Ansible? Ansible is a, I guess, tool for automating workflows. So essentially you have, let's say, like 50 Ubuntu VMs. Maybe you want to put just a default user or put a few users on it and then put Apache hosting some sort of other thing on it. That would be insane to try and do manually. That would take forever. However, you can just kind of use Ansible to do it all for you. So, interesting word there. Yeah, Lego-like configuration. So rules will have tasks, roles have tasks, playbooks have roles. So essentially you can kind of build your way up and build your way down of different things you want it to do. It's very simple. It kind of is self-explanatory as well when things go wrong for a lot of things.
One quick thing I want to mention too, the reason that things take so long, like set up a web server, it might seem easy to do, but when you have 21 teams to deploy, all running the exact same thing, it's kind of hard to do that 21 times consistently across everything. So that's where a tool like Ansible will come in. It automates big deployments for us.
So starting out first, you need your Ansible inventory file. So this is going to store all the different target hosts you have. So if you want, let's say, those Ubuntu VMs on all the different teams, and you want the FreeBSD box and things like that. So this is where you're storing all of the different hosts that you have. You're storing all the different groups. So all the Ubuntu hosts, you probably want to put it into a single group together. You don't want to just stick it a one massive long list of a bunch of IPs, because that's just going to get really confusing. And you can add variables to those as well. So like, oh, when I specify Ubuntu, I want to only do the Ubuntu group. Or if I specify Debian, I only want to do the Debian group.
Another cool thing for variables too is you can specify like variables for specific groups or specific hosts. So say every single team has a different default password. Inside of the inventory file for a group, you can specify a variable of Ansible_password and then the actual password for that team, and that will make sure it's different for every single team whenever it gets run. So it's easier for Ansible to know how to log in.
So these are examples of the inventory file. So they can be in two forms. They can either be in a .ini file, which is over on the left, or in a YAML file over on the right. Ansible loves to use YAML in order to spin up a lot of its stuff. I'm kind of confused why they chose their inventory file as an ini when they have a YAML file version of it, but you can do either one. They both work. I mean, these are pretty much it's the same file, just two different ways to organize the information. Next up, we have the tasks. So these tasks are how you carry out different actions using Ansible. So a lot of times you can use built-in Ansible modules. So like ansible.builtin.such and such. I use it a lot of times to run like very specific commands. Like if I want to test if I have connection to a lot of the routers, I'll run the Ansible built-in command module to run who am I, so I can see whether or not I'm actually connected and if I can hit all the different stuff. You can use the variables here as well. So using those different passwords, or using, let's say you want to just only change one thing and you don't want to have to change it 15 million times, you can use the variables there. And you can run them in loops or under certain conditions if you want as well.
So this is an example of an Ansible task. So first you have the name of it. You can define it, for example, here is to create admin users. So then it uses the actual module. In this case, it's the Ansible built-in user module. So Ansible has a lot of built-in modules, as Zach mentioned. There's also a lot of like external modules. Like if you want to do something on Windows, you'll have to use like ansible.community.windows or something like that. There's also like Unix-specific ones. There's a bunch of modules. Any Google search for like Ansible space something, the first link is going to be Ansible documentation, and it's really, really good. So that's very helpful. Then you specify the name of the user you want to create. In this case, we're using a variable of item.username. And item we actually get from this with items down here, this loop. And this loop references another variable called users. So that user variable is probably defined somewhere else. Could be in the group vars, could be in the inventory, it could be in the role, it could be really anywhere. But it uses this variable. So for every single user in users, it pulls the username. It then sets the password to another variable that it has called user passwords. That's what the two little brackets are because it uses Jinja 2 formatting. And then you specify what groups you want the user to be a part of. Since we're making admin users, we want them to be a part of the sudo group. And then we have the shell that we want them to have. So we're going to give them all bash. We want to create a home directory for them. So yes. Again, we talked about our loop. And then when is our condition? So the condition you can do, for example, this one right here is when item.admin is defined. So if admin is defined inside of the user, which is our item, because again, it's a loop. If admin is defined, then yes, we're going to make them an admin and do it here. You can also do it to like OS specific or hostname specific. There's a lot of variables that we'll talk about coming up at some point. I don't know if it's the next slide, but is the next slide? It might be. There's some variables, yeah, we can discuss later. And there's like a bunch of things called magic variables. Magic variables are variables that are defined by Ansible. So yeah, we'll get into that. But when you can do a condition, operating system, host name, user, another variable, stuff like that.
Something I forgot to mention. Ansible uses SSH in order to do all of this. For a lot of the Linux stuff, that's why it's so simple to use, is because it just, as long as you have an SSH connection, you're able to run Ansible wherever you want. Windows gets a little more finicky. I think there's two protocols. It's WinRM and what's the other one? PSRP. So you need to, because SSH is not on default on a lot of Windows boxes, you need to go in and change a lot of configurations for Windows, which is why doing Ansible with Windows is a little bit more of a pain than just doing it with Linux, because a lot of the times with Linux it'll just work.
Yeah. Yeah, you take roll.
So the different roles. So back to that WAGO-like configuration I talked about before. So each group task has a larger action. So if, let's say you want to install Nginx, that's not just a simple thing. You have to, there's multiple steps you have to do in order to fully install Nginx and maybe configure it with a specific website as the index.html. So it can contain those defaults for variables. It'll have maybe template files, so that index.html, things like that, or if you have specific things that you need to insert in for individual teams where you want to customize it for individual teams, you can use template files for that. And they also handle a lot of repeated tasks that you might need to do and things like that.
Yeah, handlers are typically used to restart a service at the end of something. You just call it at the end of your task. So here's an example of a directory you would see. So inside of your Ansible directory, you'll have a directory called roles, and in there you'll have another directory of your actual role name. And then it splits out into a bunch of different things. So you have another directory inside of your role thing. So yeah, directory and directory and directory. Yeah, lots of directories. But so you have your roles directory, then you have your role, and then you can have your tasks. So your tasks get executed every single time you call that role. And the file that actually gets executed is the main.yaml file. So it's going to call main.yaml. You can also include tasks from other files. If you have another file in there called zach.yaml, you can include that in your main.yaml file. But main always gets called. There's also handlers, as we mentioned earlier. Handlers are for repeated tasks, so it can be restart a service. It can be add this user, something like that. It just means when a task is run, it can call the handler right after it's done. So that's very helpful. We have templates. Again, as mentioned earlier, these are template files if you want to include a certain team number or something in there. You can use variables inside of these template files. It uses Jinja templating. It's Python type thing. So that's your directory for that. We also have files, and these are files that you might want to drop on a machine. So these files can be a text file, it can be a bash file, maybe a script or a binary, something like that. Anything you want to drop or use later on, you can put in your files directory. Then you have the vars. These are all very low variables that you can define per the role. So these ones will get executed with the role. They will not get overwritten by by your inventory or something like that. There's a whole progression of which variables take precedence over other ones. If you define Ansible_user in 10 different places, it'll be different of wherever it takes them, depending on precedence. So I'm pretty sure this is one of the highest precedences role level. Then there's defaults, which is the lowest priority of all of them. This is oh, hey, I forgot to specify the variable. Use this instead. So that's defaults. Meta just contains dependencies about the actual role. It's used for when people publish things to the community, so we don't really use it too often. And three things that we also don't use very often: library, module, utils, and lookup plugins. Honestly, I've never really touched those, but this is all Ansible documentation, so they're very cool for that. And then, yeah, we have other roles that we can have down here too, so maybe deploy Nginx, create users, something like that. So right now we've covered tasks, we've covered roles. A task is just doing one thing on a system, and a role is a collection of tasks. So doing multiple things on a system, usually accomplishing one goal, which is the goal of the role. So good things to keep in mind. Yeah. Now you might be wondering, how do I run many roles? Because you know how to run many tasks. It's just a role. But how do you run many roles? That's a great question. That's where you create a playbook. Here's Zachary Price to explain playbooks.
So, as Drew was saying, playbooks, you take a bunch of roles, you stick them in a playbook. So this allows you to just run, all you have to do, run one command, and it'll run depending on how much you have, like 10 or 20 different roles altogether. So what we like to try to do is have all the different, like Linux will have a playbook or Windows will have a playbook. So if for something happens or Windows needs to deploy, all they need to do, somebody on a team somewhere just needs to, most of the time, just hit the up arrow and then hit enter, and it'll just deploy everything. So you can also define inside of the playbook where which roles you want to run, which host you want to do it on, if you want to do it on specific groups, things like that. So, for example, here we have Linux and web server. So if they're a Linux box and defined as a web server, we might want to run this playbook on this. If they're Linux or a web server here, run the playbook. Or if they're Linux and not a web server, deploy all this stuff. So it's really useful. It collects all the things together. As you can imagine, when you have so many different things put together, there is a chance for it to go a little wrong, and debugging it's a little bit of a pain. But once you get it working, get it consistent, it's very helpful.
Here's an example of a playbook. So as I mentioned, there's a name for the playbook. You can define which hosts you want to run it on, and then which roles to run when that playbook is actually called. So in this case, it's just to create users in like this playbook. So the first thing it does is run the role create users, and then it runs the install web server role. So it runs these two ones, deploy Nginx and deploy website. So yeah, this is all one big playbook. Maybe you'll call it like linux.yaml, and then when you run Ansible playbook linux.yaml, it'll run create users, and then it will set up your web server. We mentioned variables earlier. Here's some variables. You can specify them in the inventory file. This is useful, as we mentioned earlier, if you have like, first of all, different IPs for every host. That's pretty much a variable in your inventory file. A different user for every host. That can be a variable in your inventory file. A different password variable in your inventory file. Yeah, very helpful there. Group vars are also used for the groups that you have in your inventory file. So say you have a group of all Windows hosts, you might specify to use WinRM, you might specify to use PSRP for all of the Windows hosts. You can take care of that in your group vars folder. And in there, you'll just make like a windows.yaml file. It's just like the name of your group.yaml, and that's how you'll assign variables to all of those. Then you have your playbook. You can find variables in there too. So as we just mentioned earlier, with these ones right here, how you have like roles and then the roles, you can also just specify like vars and then tell it what variables to use there. So that's pretty cool. And then magic variables, as we talked about earlier, these are things that are set automatically by Ansible. And it can be like vars for a host, so it can be like the OS, it can be the host name, it can be like a logged in user. It pulls a lot of information about the host. By default, when it does its like gathering facts phase, which is the first thing that it does when it runs, and it pulls a ton of information. You can really use any of that information as a variable. Very, very helpful. What is this? This is an example of another playbook, I guess. What's that? Oh, where it uses variables. So yeah, it also says become true up there. Become true means run this as root. And then also for Windows, it could be like run as administrator, something like that. And actually, no, this is actually just one playbook. We don't even use roles in this one. This is just a playbook that uses a bunch of tasks. So yeah, a playbook doesn't have to necessarily include roles, but it can. And then we can also add another line down here if we want to have more roles. Do we have any questions? Any questions about Black Team? Camden's question is, how can this be used offensively? It's a very good question, Camden. Camden's one of our red teamers here. And as Camden knows, we use Ansible on red team. And we use it offensively because we use it to drop our malware. So we'll have a playbook, just like you saw right there, that has all of the things we want to deploy. So maybe it's a C2, maybe it's a rootkit, maybe it's something like that. And we can just run like Ansible playbook linux.yaml, and it just like drops a bunch of malware on a bunch of machines. It might misconfigure a few services. Again, we'll have different roles for all of these. It'll ask a bunch of users. We'll have those defined in a variable. Yeah, we'll have all those things. For variables, again, like the inventory file, like per host, we might have like a certain timestamp that we want to timestamp all of our files to. So we can have them in there. But yeah, mostly just, it simplifies our deployment for when we have like 4 back-to-back competitions. So we can just like run the same thing again and again and again.
So Asa said, if I'm really interested in Black Team, how can I get involved? Well, if you do the demos this week, right, Dan? Yeah. if you do the demos this week, the demos are to go apply for the ISTS black team that just opened up. So you can work on Drew's ISTS with him. So yeah, that's open. When do they close?
Next Sunday.
Next Sunday. Check announcements or check the demos. Yes, Garrett, in Discord. So there's an announcement in Discord. I'm sure Drew will drop another one at some point. The link is in the demos as well. So yeah, if you have any other questions, Drew will happily answer them, I'm sure. Asa, a question again. How can it be used defensively? Well, you're setting up a defensive competition, so.
In CCDC, we're actually beginning to implement Ansible. And what we're going to do there is we're going to have one host. That's going to be like our trusted host. It might be like our, that's like a little insight into CCDC. You guys should all apply. But a little insight. So yeah, we're going to have like our trusted host. So like it'll be like our actual laptops that we're competing off of. And then since they're VPN'd into the network, we'll be able to trust our laptops and they can have an SSH key on them. And they'll know like, the Windows password for maybe an admin or something like that. And we're just going to run Ansible from those machines to all of our other machines in the competition and have them secure them. So it'll set up firewalls. It'll run like check rootkit, stuff like that. It will change passwords. It'll drop our blue user. It'll configure SSH. It'll configure services, something like that. So using it defensively is very, very possible. I know some people who also use Ansible to like set up like their actual like profile on a Linux machine whenever they get a new one to like set up like their bash RC, their ZSH RC, things like that. So defensively is definitely possible. What is your favorite and most rewarding part of Black Team? Zach's gonna get us going.
For me, like I said, I was inject lead like 3 years ago. That time when we just didn't have injects and needed to like go play hide and seek, that's probably one of my top ones. And then running the competition last year was a lot of fun. Getting to see all the different people and like realizing you put in work for a competition that you then saw a bunch of people enjoy is also very rewarding as well.
My favorite part, I was a part of Infra. It's my favorite. My favorite part is you are challenged with a lot of things because things will burn down to the ground before the competition even goes up. It might be a week before the competition and you're like, hey, why is none of this networking working? Yeah, when things are on fire and you're like trying to figure it out, you actually learn so much in such a little amount of time that like that's the most rewarding part is you find out how to actually learn things for yourself and you'll remember those for the next time you run into an issue. So like if any of you have any questions on like anything on OpenStack, I've probably seen it, or anyone in Infra has probably seen it before, because like there are just so many errors that happen, and like yeah, when things are on fire and you're under stress, it's actually really fun, even though it sounds like crazy and stuff like that. It's a ton of fun, and yeah, you learn a lot that way. So that's my favorite part. Thanks for coming in today.